Okay, guys, we are on day 3 of Unit 10, and we're talking about directed line segments. So in our warm-up, it just talks a little bit about ratios. And so it says if Mrs. Ham's class is divided into a 5-to-6 ratio of girls to boys, what is the minimum amount of students in her class? What is the fractional amount of boys? And what is the fractional amount of girls? All right, so because we are divided into a 5-to-6 ratio of girls to boys, that means that there's 5 girls and 6 boys. And that's 11 students, and that's the minimum amount. And they say minimum because ratios can always be reduced like fractions. So it doesn't mean that there is 11 students. It could be that there are 10 girls and 12 boys. And so therefore there could be 22 students in our class. But ratios are always reduced. And so when you divide both of these numbers by 2, that's how it reduces to a ratio of 5-to-6. All right, but because they said minimum amount, we don't have to worry about the maximum amount because there really wouldn't be one that we could figure out. They also want to know what's the fractional amount of boys. And so we have to remember fractions are a part out of a whole. So a lot of people want to turn a ratio of 5-to-6 into a fraction of 5 out of 6, but the 6 doesn't represent the whole. So because they want to know the fractional amount of boys, remember that boys is 6, and so that would be 6 out of the whole, which would be 11. Okay. When they ask about the fractional amount of girls, since there's 5 girls is the part, the whole would be 11 again, and so the girls would be 5 out of 11. Okay. And so this is boys, and this one is girls. Okay. All right, part B. So they said if a line segment is divided into a 3-to-2 ratio, what's the minimum amount of equal parts that the line segment is divided into, and what fractional amount is each part to the whole? And so because they're saying that we have a 3-to-2 ratio, that means 3 parts on one side of a point and 2 on the other. And so 3 parts plus 2 parts would equal 5 parts. And again, they're saying that's the minimum amount because, again, ratios could be reduced and there could actually be a lot more. And they want to know what's the fractional amount of each part to the whole. So that would be 3 out of 5 and 2 out of 5. So 3 parts out of the 5 whole parts and 2 parts out of the 5 whole parts. Okay. All right, guys, well, we are going to find a point on a directed line segment today. And we're going to cut up our line. Now, we could cut it up with midpoint, but midpoint, there's a problem with it. It only cuts a line segments up into 2 equal parts or 4 equal parts or 8 equal parts. And so anytime it's something like 5 equal parts, like in the warm-up, we can't use our midpoint. But slope, when we do rise over run, cuts our line segment into usually the right number of points or parts. And so we are going to go ahead and graph the 2 given points and connect them to form our line segment. We're going to calculate the slope between the 2 points. We're going to use rise over run to cut our line segment into a bunch of different points, okay, as many as possible. And we're going to hopefully make sure that our line segment has been cut up into the correct number of parts or line segments. Okay. And then we're going to go ahead and determine which point on the line segment they actually want as the answer. Make sure that you pay attention to which end you are starting from. So which end is your start and which end is your from, okay? All right, so in number 1, it says in the diagram below, AC has endpoints with coordinates at -5, 2, and 4, 10 for C, 4, -10 for C. And they said if B is a point on AC such that AB to BC is 1 to 2, what's the coordinates of B? And so if you take a look, we want A to B and then B to C, 1 part to 2 parts. So we want 3 equal parts. And therefore, we can't use midpoint from 3 equal parts, okay? So we're going to see if slope works instead. And so we're switching formulas. So remember, M stands for slope, and it's y's to the sky. So we take our y coordinates, and it's subtraction on top. So we take -10 minus 2. Because I chose that order, I have to start with 4 on the bottom and then subtract my x coordinate of -5. All right, so let's clean up the top. -10 minus 2 is -12. On the bottom, 4 minus a negative 5 is the same thing as saying 4 plus 5, which is 9. Remember, slope must always be reduced. If you don't know how to reduce this fraction, type it into your calculator, negative 12 divided by 9, hit enter, math bracket, and it will turn it back into a fraction of negative 4/3. All right, and so we have to remember that negative 4 is our rise, and that 3 is our run. And in order to rise a 4 to go down, we're going to start at A, and we're going to go ahead and rise down 4. So 1, 2, 3, 4, and run 3, and we're going to drop a dot. We're going to do it again, down 4, run 3, drop a dot, down 4, run 3, drop a dot. And this is awesome because it tells me that I did my slope correctly since I got right onto C there. All right. And if you notice in our picture, we have 1, 2, 3 equal parts. And so we just have to remember that we are going and having AB be 1 equal part. And so I'm going to go ahead and put B here because that would be 1 equal part. And then BC has 2 equal parts, 1, 2. And so now they want the coordinates of B. And so I can go ahead and tell them that B is at, let's see what it is, negative 2, negative 2. All right, so that one's finished. All right, I'll see you guys on the back side of notes for a few more.